Hi everyone. I am recording this session as part of the GIS 101 class. I always like to start off with an interesting map. So this is a map showing incarceration rates across the world. And it also, one interesting aspect of this, you may notice that the countries are not in their regular shapes. It's because the size is proportional to the total prison population, but then the colors indicate the prison population per 100,000 people, which is kind of like an incarceration rate. So you can tell a lot of different stories with maps, and as we've talked about, that's one of the fundamental aspects of GIS is telling a story with a map. So in this session, we'll go over the basics of what GIS is, what you can do with GIS, what are some of the components of GIS, and then we'll kind of get into some of the basic aspects, talk about raster and vector files, and latitude and longitude. So GIS, you should have, maybe not a definition memorized, but certainly a working understanding and be able to describe what a GIS is. There's no one universal definition, but this is a pretty good one from Esri. It's a computer software that links geographic information with descriptive information. So it's basically where things are and what's there. What's really great about a GIS is that unlike, as you can see here, unlike a flat paper map where what you see is what you get, GIS can present many layers of different information. And that's really the power of GIS, is that you have a lot of information behind what you're seeing. So it's all about the spatial data and then the tabular data. Sorry about that, I had to find my laser pointer. So it's about spatial data and tabular data. So it's what you see on a map, but there's also a lot of data behind that, that it's all in table form. And you'll get used to this as we go throughout the semester, but that's the true power of GIS, is you have all this information behind what you see. So what is a GIS? It's a geographic information system. You should know that. Captures, stores, and manages data. We've talked about how data are really important. We also talked about how data is actually a plural word for datum. So singular is datum, like a single data point is a datum. And then data, that's a more than one datum. And so you can visualize and represent data, but also the real power of GIS is this spatial analysis side of things, where you can do, as you'll see throughout the semester, a lot of different ways to spatially analyze things. So there's a really good, this is part of your reading this week. I'm just going to sort of show you here. Make sure you watch this video. I'm not going to show it here just in the interest of time, but definitely go through this reading, which is again linked to your assignment this week. Some really good I guess, insight into what a GIS is, and there's a short video here about what a GIS can do. And so you definitely want to watch this video this week. There's a lot of really good information in there. And so one of the bottom lines of this video is that a GIS it's a really powerful tool that can be used for basically any industry. If you name any industry today, almost certainly they'll be using GIS in some way, shape, or form. It's really big in emergency services. A lot of engineering firms use it, civil engineering, environmental engineering. A lot of policy, a lot of folks use it in the policy world for planning purposes. City planners certainly use it. People that are designing neighborhoods and any kind of infrastructure, human infrastructure, are going to use a GIS because there's a spatial component and there's a bunch of different considerations. But it can really be helpful for things like if you're managing logistics. A GIS, you can input all kinds of different like customer data and whatever you're providing in your logistics. And GIS can really quickly help you plan efficient routes and whatever your goals are, whether it's the quickest time, the shortest distance, the least fuel spent, whatever the case may be, you can do all of that. It's a really good planning tool, so you can have GIS of a certain area and plan buildings, roads, businesses, schools, you name it. So you can look at like what's going on around an area, see if there's enough population in an area to build a new business or build a new school, and then see how long, the connectivity of all the roads around that business or school and how long it should take the average person to get there. So there's so many things you can do with it. And so no matter what you're studying here, GIS can help. And it's a big part of a lot of the engineering fields. So it's a good skill to have. At the core of it, GIS answers geographic questions. So what does that geographic questions mean? It means there's a spatial component. And we talked about that. Remember, geographers are concerned with pattern and process. So you're looking at what's there on the surface of the Earth and then figuring out how it got there. So the where and the sort of why and the how of things, right? And so if you see, for example, this is obviously a map of the world, and you see the pattern. And so a geographical question that this is answering, there's a number of them, but one of them could be where are all of the countries of the world relative to other countries? Now, in this case, what's interesting about this is called a transmercator projection, is that it does not answer the question which countries are bigger than other countries, because we'll talk about this later when we talk about projections. The only accurate representation of area is really near the equator, which would be around here, okay, or down here, sorry. Down here, the equator is hard to see here. There's the 0 line. So these are about the right size. Let's put it this way, Greenland is much smaller than Africa, for example. So Greenland up here, which looks about the exact same size as Africa, the entire continent of Africa, is actually much, much smaller. And Alaska is not that big. Russia's not that big. So the further you get away, the more distorted it gets. And so it's not answering that question. It does. It just so happens to answer the question: if I wanted to travel from one country to another, which direction would I go? This is actually does hold on to direction. Anyway, the point is, you could make this into GIS, and it's answering a question. I want you to just press pause and stop and think. This is a map that we looked at earlier in the semester, and think about what geographical question this answers. I'll just leave that to you. And here's another map that we looked at. Of the religious affiliation across the United States by county, and so you can think about what geographical question does that answer, right? So at its core, a GIS answers these geographical questions, and as we go throughout the semester, I'm going to have you pose questions and answer them, and ultimately your final project is you're answering a geographical question, and so that's really at the heart of a GIS. So GIS can do a lot of things, as we talked about. It's certainly a data management tool. We'll be working with data a lot this semester. We'll be pulling data from various sources. You'll be sort of generating your own data. You'll be taking one piece of data and appending it to another piece of data and then visualizing or symbolizing that on a map. There's a lot you're going to do with data. But there's always a visualization involved because, again, a GIS is a representation of something on the surface of the Earth, and so mapping is a huge part of that. Again, spatial analysis is the true power of a GIS. You can do a lot of different spatial analyses with it. But I think a really important aspect that we haven't really addressed is communication. So GIS is a great communication tool. Just think about any number of businesses or organizations or governments or whatever you see online, and they give you a map of whatever. It's a good way to communicate something. Let's say you're providing some sort of social service to citizens of the state of Delaware, and you want to show all of the give a sense of where you're doing your work and what kind of work you're doing. You can put a map online that shows we've addressed these needs of these people in this area and saved this much money and provide whatever you're doing. Maybe it's a health, someone that works with health issues with low-income populations in the state, and you say we've helped avoid this many hospital visits in this part of the state or whatever. Right, so you can visualize just about anything and use it as a communication tool for basically whatever you're doing, as long as there's a spatial component. So there are sort of these fundamental components of a GIS. So hardware is, that's computers and LiDAR. Maybe you're using survey equipment. So anything that's like a physical piece of equipment that you're using. Software, obviously that is anything that's programmed. So ArcMap is a piece of software. ArcGIS Online, that's a piece of software. Excel, whatever you're using, those are all pieces of software. So that has to do with programming. Data, that's another really important component. And we talked about that. I mean, you really can't do anything in a GIS without data. It's absolutely at the core of GIS. Then part of the GIS, a really important part, and that's kind of a lot of what you'll be doing this semester, is learning some of the procedures and methods. So using the software, how do you do things with the software, how do you use the hardware out in the field to capture data, like those are all processes. And then people. A GIS, right now, until AI takes over, it requires people to work. Okay, and remember, always, always, always has to be a spatial component. Okay, there always has to be a spatial component. Right, and remember, as a geographer, which GIS is part of geography, it's the belief and the understanding that things that you see out in the world are not there randomly, that there is a process behind all of it. Okay, and so it has to be spatial. What does it make? What makes it spatial? Well, basically we know it has to do with space, and we know where it exists on the surface of the Earth. Now, okay, we could be mapping the moon or Mars, and that's, so not on the Earth, but whatever planetary body you're evaluating, you need to know where things are. Okay, that's what makes it spatial. Otherwise, it's just not, if you don't know where it is, it's not considered spatial. All right, so we'll talk about this throughout the semester. We'll address this right now. The geographic coordinate system, excuse me. That's exactly where things are located on Earth. Okay, so that's you have a point, whatever, in your neighborhood, or look out the window, or wherever you are, wherever you're sitting, that exists somewhere on the surface of the Earth. And so the geographic coordination system will allow you give them the coordinates, give someone the coordinates, and they could find exactly where you are on a map. Okay, that's geographic. Now, a projected coordinate system is a little bit different. The key to a projected system, and we'll get into this later, it's a little deeper than we need to go right now, but what underlies this is, if you think about it, geographic coordinate system, or GCS, we're finding where we are on this sphere, or spherical. It's not a perfect sphere, but where we are on basically a sphere. Okay. Well, your computer screen is not a sphere. You have to display it somehow. So this is a projected coordinate system, and there's different ways to project. This is not the only way, and this should look familiar. This is the same projection that I showed you a few slides ago. But there's different ways to project a spherical surface on a flat surface, and that's what's the projected coordinate system. There's different projected systems for different purposes, and we'll talk about that later. But just to give you a sense, when you represent something that's on a spherical surface on a flat screen, you have to make some sacrifices. You can't perfectly do it, and that's what a projected coordinate system does. Okay. Just a couple notes about scale when we're looking at scale, and this is really important to understand and be conversant in. A small scale is what's a small ratio. So a 1 to 500,000 scale means 1 inch on a map represents 500,000 inches in the real world. Okay? A large scale would be a larger ratio, right? Like, so 1 to 50 would be 1 inch is 50 inches. The way I always remember this is, if you have a small scale map, you can represent a large area in a really small map, right? Because things are 1 inch is like 500 inches, or however many feet that is. And a large scale would require a large map to display the same area. Okay, so however you remember it, just remember that small is a small ratio and large is a large ratio. And you don't need to write this down, but these are just some examples of some of those different projected coordinate systems. Okay, so you can see these are all different, but these are all different ways to project, in this case, the map of the world on a flat surface. Okay, so you have to do some distortion. But then when you get to geographic coordinate systems, which remember is where something actually exists, we're going to deal with latitude and longitude. So I want to make sure you understand latitude and longitude. The latitude is the east to west lines. Okay, so these are lines of latitude here. Line of latitude, line of latitude, line of latitude. All right, so the equator, which hopefully you're familiar with, that's the line, a line of latitude, and that's the 0 degrees. You go north, it's degrees north, right? So 10 degrees north, 20 degrees north, 30, 40, up to 90. So the North Pole is 90 degrees north. You go south, and the South Pole is 90 degrees south. Okay? So that's latitude. And then we have the tropics as well. Those are lines of latitude, Cancer and Capricorn. And so when someone talks about the tropics, that's technically what they're talking about, is this area here. Longitude, as you may have guessed, are these lines that go the other way. And these are also called meridians, whereas latitude are called parallels. Why are these called parallels? Because if you look down here, they're all parallel to each other. They never cross. Whereas longitude, they do cross, and they cross where? At the North Pole and the South Pole. All right, so these are your lines of longitude. Okay, and so our starting point for longitude at 0 degrees goes through Greenwich, England. If you see England up here, it has to do with like the history of this and the Royal Observatory in England. And so that's your 0 line, and you go east degrees, west degrees. Okay, east degrees, west degrees. East of the prime meridian, west of the prime meridian. Pretty easy. And since this goes all the way around, right? These lines of longitude go from here to here to here to here. You go from 0 to 180 on the other side of the Earth. Okay, 0 to 180. And 180 is over in the Pacific Ocean. Okay, so that's longitude and latitude. How do you remember this? The way I remember it is longitude lines are all long. So if you look at these lines, they're actually all the exact same length because they go all the way around. Whereas latitude, they get smaller and smaller and smaller and smaller as you go away from the equator. So if you go right up by the North Pole, I mean, that's a really tiny, it goes to a point, technically, right? So longitude lines are all really long, whereas latitude gets shorter and shorter. Okay, so how is this expressed? Excuse me. There's two different ways to do it. For now, we'll stick with what are called decimal degrees. And so basically you do latitude, longitude. All right, so let's look at 0 north, 0 east. So that's 0 north latitude, which is going to be the equator. 0 east longitude is going to be on the prime meridian. So it's where those two meet right here. Whereas remember, it's the Greenwich Observatory. That's the line, the prime meridian. And so that's at 0 east, but that's at 51.5 degrees north. What is that? So 0 east, right here's your prime meridian. 51.5 north, you take the equator, and you go up, and you see this makes a 51.5 degree angle. And that's where that line, this is the 51.5 degree north line of latitude is right here. Okay, so that's how you get those lines, right? So if this is 15 degrees, that's a 15 degree angle right here. All right, here's a 30 degree angle, here's a 50 degree angle, here's a 70 degree angle, okay? And then Pittsburgh is at 40.4 degrees north, so you go up at 40.4 north angle from the equator, and 80 degrees west, so you go actually at 80 degree angle from the prime meridian, right? So here's the prime meridian, and that's an angle of 80 degrees from it. Okay, so that's your 80 degrees west line of longitude, goes right here. Okay, and then here's your 40.4 line of latitude. Okay, so those are called decimal degrees. You can see there's a decimal here. Okay, so we'll stop there for now and then pick up with the rest of the presentation in a minute.